Tutorial, I'm going to look at how we can write to hdfs from Spark. We're going to try it in two different modes. Firstly, we will be running it in a yarn cluster. So we'll be going to a terminal and be using the Spark submit command. And then secondly, we'll be running it in local mode from within Eclipse itself. The code is already given in the previous tutorial, but I'll quickly go through the code. It's basically you're creating a Spark conf and we're calling it a Spark simple. That'll be the name of the Spark job that'll appear on the Spark UI as well. And I'm creating a list of strings, which is a CSV base. So there are two entries here. One is 123, which is the order ID, comma John, and 456, comma Peter. So just a list of two string values. Each string value is like a comma separated value as in CSV. And then we are creating a Java Spark context and passing the conf that we created here to it. And then we are providing an hdfs path. So I'm going to create this file, and this is called orders by customer from spark.csv. Actually, the .csv is not required. So when you write it from Spark, it's going to create a folder with that name, and you're going to have multiple part files inside that. So this could have been easily without the .csv. And then here, firstly, I will show you without putting the coalesce in. So coalesce, what it does is, if you have multiple partitions, you end up getting multiple part files, part 00, part 001, and each RDD partition will be written to a separate file. If you don't want that and you want all the RDDs to be written to a single file, you put a coalesce here. So first try without coalesce, and then we will try it with coalesce. So I'm going to save this again. So that's a simple code here. Now to run it, as I need to package it as a jar file because I'm going to run it outside in a terminal window. So I'm going to say run as maven install. So this will create the jar file. So while it is running, I'm going to go to the hue and see if already there is a folder. I'm going to delete it. If anything from, say this from my previous run, it's inside that folder. So I'm going. So now I have deleted the orders by customer from Spark CSV, which I ran earlier. So once it's deleted, now this code has already been built within Maven. So as a jar file is built. So that should be in the target folder already. So I'm going to the terminal window. This is the last job that I ran. I mean, if you want to see your previous jobs, you can type in history, grep Spark submit. So it'll give you all the Spark submit jobs you ran in the past. So here I know I just ran it earlier, so I do an up arrow key. So this is the Spark submit command. So you do Spark submit, master is yarn. So I'm running in a yarn cluster. The deploy mode is cluster mode. I'm running with 128 MB executor memory and 128 megabyte driver memory. The default, if you don't put these two values, the default is 1 GB. And in most industrial level applications, you will be running with 6 GB or more. So this is because of trivial application, it doesn't need much memory. And the class that is going to execute is com.mytutorial.spark to write to hdfs. That's a class here with the main method, spark to write to hdfs. And then the jar file that contains, that's the jar file we built. So it's inside the target folder. So home Cloudera project, simple Spark is the project under which you got a target. And when we built the Maven clean install, would have put this class file into this particular jar file. So that's all we require to run this. So if I press enter, it will start from the accepted mode. And sometimes if you're running it in a quick start and you don't have enough memory in your system, there are so many services running, the few tips, you can go and exit out of Eclipse because Eclipse might be taking its own memory. And the other thing you can do is maybe go to the Cloudera manager and stop some of the services that are not used. For example, like Uzi workflow, You can't stop HDFS, you can't stop yarn, and you can't stop the Spark services. Maybe you might be able to stop the HBase service because you're not using HBase. You might be able to stop the Uzi workflow and so on. So it's still running in. So now it's gone from the accepted mode into the running mode. You can also see what's happening from the job browser. So if I go to the jobs here, I should be able to see what jobs are running. It might have already been finished, not yet. See here in the job browser, you can see these are the jobs. Before it failed, it didn't have enough memory, then it succeeded and ran it again. Now this is the job at the moment we are running, and there will be a job ID as well. Yarn would have given you the job ID. We can use the same job ID to go to the terminal window and look at the yarn logs via command line, or you can go to the Spark history server as explained earlier in the previous tutorial, and you can look at the history. And also you can go to the Spark UI with that ID and see how this job has performed, how much memory it has used, and so on, how many executors it has used. So let's check if it is still running. Yes, it's still running. So generally a trivial job like this shouldn't take this long. So it's because of our constraint for the resources. It's only a 16 GB laptop. It's only 12 GB is allocated to the VMware. So while it's being run, I'm still going to go into the files. So I click on the menu here, and then I'm going to go into the files. See, now it says succeeded, so the job has finished. Now I'm going to see whether the file has been written to the HDFS. So I go to the files here, I click on the learn HDFS, which is one of the directories I created to learn. For some reason I go to click it twice. Now you can see orders by cust from spark.csv, a folder. So this is a folder has been created by the Spark job. So if I click on it, now we'll see part 00, part 001. So two part files have been created, so that knows two partitions were created for each entry. So part 00 will have the first one, 1, 2, 3 John. Then I go back, the next part file 4, 5, 6 Peter. So it has been created. So now we will see how we can run it in a local mode from within Eclipse. So this particular one, if I had put a coalesce in as shown, then it would have only created one file with 2 entries in it. We will see that in the local mode. So if we go here, if I had changed this to coalesce 1, control space to code, so it says number of partitions I need. I'm saying only one partition I need, and then say save as text file, and if I run it again, it would have created one part file. So let me go and delete this folder again, and I'll be running it from the local mode. To run it in local mode, I have to make a couple of changes. See here, I didn't put the host name of the edge node or whatever because I'm running in the yarn cluster. It automatically knows it's in HDFS mode. But if I run this as a local mode as it is, it'll try to write it to the Unix file system with that path in it, and it wouldn't be finding this folder or whatever, and it'll fail. So here are the two changes I need to do. Here, firstly, I need to do set master, and inside that I need to say local. You can put asterisk, or you can put 0, 1 or whatever to say how many threads to use. So this will be using multiple threads. If you want to run it with 1, you just say put 1, so it will be running with 1 executor. And that's one change. The other change, as I mentioned before, if I put it like this, it's going to try to write it to the local file system. So here I need to put the protocol hdfs, then I need to say it's quick start .cloudera, that's the host name, and that's a host name, and 8020 is the port on which the name node will be running. So it's hdfs quick start Cloudera 8020. So I'm going to save this. I'm going to select Spark write to HDFS, and I'm going to say run as Java application. And you will be seeing in the console will be running, so you can check for any errors. So the job has run and there are no errors. Now I can go to Hue and check, refresh here. I can see if a new folder has been created, and under that folder there should be only one part file because we use coalesce to one. That means both the entries should go into one part file. So here we go, orders by cust from Spark CSV, that's a folder, and here's one part file. This success is saying the status is success, and click on part 00 and 123 John 456 Peter. So this is in local mode. So let's go back and look at that. When I ran it in the yarn cluster mode, at the end when the job has finished, it gives you an URL. So I'm going to copy this URL and I'm going to inspect this job in the Spark UI manager. So I go to the browser again, open a new window and Control V and press enter, and this should bring up the Spark UI window. If it is not bringing it in, you have to look at the one of the module 1s and module 2 before running a Spark job. There are some configuration and settings that has to be done. Okay, so here it says even though failed, the job has run. Sometimes the job tries to write it first time, it fails it, then write it second time. So because we had the resource constraint, it tries it couple of times, and then if it fails all the time, the whole job fails, but sometimes the second time it succeeds. So you can drill into here. So this is basically the Spark UI window. It gives you the job, stages, executors and so on. So here says failed tasks 1 so a couple of times it failed, and then sort of it's here it's passed, succeeded task 1. Then if I go into executors, I can see how many executors were run. See, these are all the executors that ran, and this is the executor that failed. So you can go and see why it failed. It could be due to memory constraint or whatever. So if I go and click on it, it's not showing anything. So you can, this is how you can inspect all your application. This is the driver on which it ran, and these are the executors on which it ran. So completed task 111, total task 111, course, so everything is looking fine. So we were able to create it. Total task 2, completed task 2, and failed task 0. So you can also look at your job history. So if you want to look at all the history, that will be running the history server. This is the Spark UI screen, and the Spark history server will be running on here. So you can see all the different jobs that you ran, and everything is ordered by the application ID. And also we saw earlier, if I go into the Hue again, here it is. In the Hue window, it normally writes to a path in the hdfs all these Spark runs that were run on the cluster mode. So if I go to user and I click on Spark, and see application history. So this is where it writes it to the hdfs as well. The Spark job will be writing it, and you can see these are the different job IDs. So you see this is the local mode you ran it in, and these are the other application IDs that were ran in the yarn mode. Just interesting to see if the local mode shows in the history here. So another way to go into the history server is via the Cloudera manager. So I type in with login with Cloudera. So log into Cloudera, and then I can click on the Spark service, and then in the Spark service there should be a web UI that takes you to the history server. So here's the Spark. So I click on, oops, So click on Spark. So it has gone to Scoop actually, so go back again. Scoop is a tool that you extract data into hdfs from the relational databases like Oracle, MySQL, Teradata, and so on. So I click on Spark. So I'm within Spark now. So here's the URL to History Server Web UI. So I click on the History Server Web UI. That should give you all the Spark jobs. See, here are the jobs that we ran. That's all today. And if you had run anything on the local mode, it's showing here as well. Spark Simple. That's the application name, count Spark. So this is the previous one. So we ran with the Spark count. So this is not the today's run, but you can also run it in a local mode via the Spark Submit. So when you're running the Spark Submit here, so if you run it from within Eclipse, it's not going to register that, but you can run it master here. Instead of yarn, I could say local, and when you run this, it will be registered in the history server. So that's all for this tutorial, and in the next tutorial we will see how we can use Spark to read the data that we have just written. So we have now written a file to the Spark here in Hue. You can see it, couple of entries in the part file. Now we'll be reading this in the next Spark job. So any typical ETL tools, that's what it will be doing. It will be reading some data, it will be doing some transformation. For example, it will be reading an XML data, transforming it into Avro or Parquet, which are more HDFS friendly binary data formats that are splittable, compressible, and so on. And then it will be writing to the HDFS in a more stored and organized manner.